Yeah, if I do first period, there will be no random stuff. It's all business. Okay, you guys got this down? Yeah? Okay. Henry, did you get this down? Okay. So I'm going to explain the concave down one, okay, which is this blue one or purple one, okay. The red one, which is concave up, I like to think of it as a cup. Concave up, C-U-P, okay. Concave down, I like to think of it as Canadian, C-D-N, Canadian, okay, concave down. Yeah, that'd be mine. Okay, so if you take a look at the blue graph and if you draw a little bit tangent lines, can you guys see that yellow up there? Does it show up? It doesn't? Okay, I got to change the colors then. Aqua. Nice. What's with this guy? I'm not playing video games with you, boy. I have no clue what's going on, honest. I think Bill Gates has taken over my machine. Okay, so if I draw tangent lines here, okay. Okay, you guys need to pay attention here, okay? It's all that random stuff that's getting recorded, Heather, and you're complaining about it. You are the random event. Okay, do I need to explain number 2 to you? Is the graph below the tangent line? Yeah? You guys got that okay? All right. Take a look at the tangent line here, okay? Remember the tangent line, the derivative is also called the slope of the tangent line. Do you all agree that the slope of this tangent line here is some positive number? Okay? What is it here? Here. Okay, so you know it's some positive number here. You know it's 0. Do you then agree with statement number 2? That the derivative is decreasing. In other words, the slope of these tangent lines that you see are getting smaller and smaller and smaller. Yeah. Once you go on the other side, now you got to think about the other side, okay? The slope is negative, okay? It's a negative number. But you can see that it's getting a lot steeper here, isn't it? Right? It's getting a lot steeper here, okay? So here the slope might be like, say, -6. Here it might be -2. Well, isn't this smaller than this? My bad. Isn't this smaller than this? Okay, isn't the derivative decreasing then? Okay, because -6 is smaller than -2. Therefore, it's decreasing. No, you're looking at it from here and you're going down this way here. Even if you were to look from here, see, it's going positive, it's going to 0, and then it's getting negative and more negative. So obviously, right across, it's decreasing all over. Because it's going from a positive number to a negative number. So, if it's going from a positive number to a negative number, it's decreasing. You guys with me on that? Can you kind of fill in your notes for the red one then? So, what I want you to do is I want you to, yeah, I think Gates has taken over my machine. What I want you to do is draw the tangent lines on the red one and show me how f prime is increasing. You guys with me on that? Tati? You zoning out there on me? Okay. Well, I'll pause here, come around and see what you're doing. Let's get this out of there. Okay. Next slide is going to be pretty busy, okay? So remember what we did was the first derivative test. And it's called the first derivative test because there is a second derivative test, okay? So today we're going to do the second derivative test. So let's take a look at the first derivative pictures. So this is really a rehash. It's a pretty busy slide, so copy it all down and then I'll explain to you. And it's all color coded, okay? It's all color coded. So, sorry? This is the first derivative test. So everything is color coded here, okay? So the black equation goes to the black graph. The red equation is the derivative of the black equation, and the red graph goes with the red equation, which is the derivative, okay? Canadian. What does CDN stand for is what you say, concave down. The y value on this thing here is all negative.
Okay. What is that?
That means this. Because that graph is f double prime. Okay? Right? All right, now we're going to look at the part where it's changing concavity and becoming up. Okay, see how it's concave up here? Okay? And here's my second derivative. What can you say about the second derivative?
Up in f prime prime is greater than 0.
Okay, can you make that statement, please? Write it down. So again, concave up is CUP, cup. If, Tati, what were you saying? Greater than 0. What do you think f double prime is here? 0. So point of inflection, POI, point of inflection, if f double prime equals 0. Okay? All right? So you can see where the second derivative is coming in now. Okay, second derivative. And you guys know why this is coming in at the point at which it is, right? Because you can see that when it's concave down, this point here is a... Nice. Good. Was that you, Teddy? Awesome. Good job. That's a max. And when it is concave down, this is a min. Okay, so you can see it's kind of tied to what we just did, except we are looking at second derivative now. Okay? You guys with me on this stuff? Yeah? Okay. So those are pictures, and then we have words. So here are the words, okay? You just did, yes. But I want to show you this little caveat on page 193. So you need to open your book on page 193. There's a little table there, and then there is a little paragraph underneath that table down at the about 2/3 down that page. Stephanie, nice colored notes there. See, it makes a lot of sense. If you read that, you can see exactly what's going on. Good job, girl. Okay, page 193. At the bottom, there's a little chart like 2/3 of the way down the page. And then underneath that, there's a paragraph, okay? And all it's saying is that if f double prime is 0, then it is not necessarily a point of inflection. If it's a point of inflection, guaranteed f double prime is 0. But the contrary, the opposite statement doesn't necessarily hold, okay? The converse. I was thinking of the word, man. I haven't done geometry in about 6 years. I forgot the word. Remember converse theorems? You have if something, then something. Converse, you reverse those things, right? Reversing hypothesis and conclusion. Didn't do that in geometry? Should have done that in geometry. Okay, you guys all right? Okay, can we work on a problem then? All right, so I did all the theory for you. Let's go do a problem. I'm trying to get this whole thing down on one page, but I'm having a hard time. What do? I want to really get this whole thing. Okay, why don't you get the stuff down up to here, and then I'll scroll, and I want to show you a table that we need to do, okay? Okay, I think I've got pretty much the entire table there, so let's start working on this. So this should be a find f prime, okay? And the equation is fx equals x cubed. So critique, what's f prime?
F prime is 3x squared.
Nice, good job. Chris, f double prime.
6x.
Nice, 6x. Ed, point of inflection.
0.
Nice, good job. Okay, so now you're going to have an interval from minus infinity to 0, 0 to infinity. Okay, Stuart, pick a point between minus infinity to 0. Negative 1, put it in here. Put it in the f double prime equation. So you get a negative number, and negative would imply Canadian or cup? Canadian, nice. Okay? So you pick minus 1, right? Okay. Jonathan, your turn. Between 0 and infinity. Pick a number.
1.
Don't listen to Henry. Okay. Henry's broken his legs. Before he leaves this room, I think I'm going to bust his head as well. So don't listen to him. Okay, Jonathan, think. 0 to infinity. 1. Put it in here. I didn't know there was a Jonathan sitting out that side of the room. Jonathan, do you get positive or negative number? Positive. Okay, Monica, is that a Canadian or a cup? That's a cup. Okay? And I also use this P to remind me that positive, the second derivative has to be positive. This N, second derivative has to be negative. Okay? So you got a lot of tools there to help you memorize these things. You guys with me on this? Is everybody okay? All right. You're going to do this entire problem on your own, and then you can always check with your graphing calculator when you get it done. So you're going to do this problem. Sorry? I like doing easy stuff. And then I like to make you guys sweat out the other stuff.